polar coordinates.
Yeah.
Yeah, it's kind of weird, actually. Between 32 and 0 and negative 40, there's a lot of funny Celsius. And we call these polar coordinates because they are based on a pole and they're radial. So it's a circular system of locations. And so this is a circular. Can anybody think of a real circular system that we use all the time? Latitude, longitude. Yeah, our GPSs use basically a polar coordinate system. It's different, it's very defined for the Earth, of course, but it's the same kind of idea. Okay. So if we're gonna convert from polar to rectangular coordinates, and then we're gonna learn how to graph in polar coordinates. And you get some really neat designs, actually. This is where those graphs of flowers and stuff that you probably have seen come from, polar coordinates. Just so I can find my grid here. And special needs. Let's see if that works. Nope. That cheated. How about you? Okay, I'll just draw it. How many of you remember the unit circle? Yay, right? Yeah. Okay, so what's the radius of the unit circle? 1? Okay. If I say that this angle is pi over 4, what are the coordinates of that point? If these are rectangular coordinates, correct? Cartesian coordinate system, move 2 over. So our x value is root 2 over 2, right? And our y value is root 2 over 2. Wow. Big one. Let's get that. Eraser. This be. What the worst? Oh, of course. I'm going to do this all day tomorrow. All right, so you have an x and a y, correct? Is okay, in polar form. Let's have a default. We measure angles or points with the radius and the angle measure. Okay, so what would the polar coordinates of that point be? 1 power 4.
Whoa.
See, so all it is an angle, and then how far out do you go? Okay, polar coordinates. We can also transfer between the two. How can I calculate the radius, r, based on the x and the y value? Yeah, it's Pythagorean theory. So, square root of x squared plus x, right? So if you want to find the radius, you've given rectangulars, So we're going rectangular to polar here, right? You're given a point, Pythagorean theorem gives you the radius. How can I find the angle? Theta. I'm not trying to trick it for you. 10. It's gotta be the inverse. Yep.
Oh, yeah.
Because tan theta is y over x. Theta is the tan inverse. Okay, so there's transferring rectangular to polar. Okay, you can calculate that whole place. All right. Make sense? Trig? Okay, how about polar to rectangular?
The exact opposite.
How do I get x? I'm given the angle and the radius. So I have to use those. I want the x value. Sine or cosine?
Cosine.
Yeah. Cosine theta, remember, is x over the radius, right? So x is r cosine theta. Yeah? What would the y be? R sine theta. So you can transfer between polars, rectangulars, and back again. Right? So we're basically making a circular system of finding your location. Okay? Any questions there so far? Do I need to show you examples of transferring between the two? Yeah. Everybody just looked at you. Okay, so let's, real quick, if I give you, that's right. R theta is 3 and 3 pi over 4. Okay. What are my x, y's going to be? X is r cosine theta, right? So my x value is 3 cosine 3 pi over 4. My y value is 3 sine 3 pi over 4. Right? So then I'll just calculate the values there. So this should be negative root 2 over 2. Right? Negative 3 root 2 over 2. And sine of 3 pi over 4 is root 2 over 2. There you go. Okay. What about, let's see, 3 equals? R is square root of x squared plus y squared, right? So 13. And theta is tan inverse 2/3, which is that one I know off my head. It's the decimal. Okay. So we're transferring to the none. Let's see here. You didn't just fill that out of the book, did you, Ron?
No.
If you have a line passing through the origin, how can we write that in polar form? Any ideas? Is the line gonna have a defined radius? No, it's forever, right?
So just a bunch of people.
Yeah, it'll be just defined on, so it would just be some angle. So, how would we write that? So the equation of a line might be like theta equals pi over 3. No radius. So, pi over 3 is somewhere in this direction. All it is an angle. The radius is changing. Gets a little bit more fishy when you do it not passing through the origin. D secant. So it involves secant because of the right triangle aspects of it. D alpha, I don't know why they chose D and alpha, honestly. The point D alpha is the point on the line closest to the origin. So again, it's just a point. In rectangular coordinates, closest to the origin. I'm pretty sure you're not going to run into this on the AP test, okay, but there it is. It's the line not through the origin. It's defined by the angle, but secant because of the right triangle trig and then position it with a point close to the origin. That's just more of an FYI on my part, so let's see. Let's graph one of these functions. Let's do 2 cosine theta minus 1. It's pretty standard. Okay, what's the period of cosine and sine? If you graph, you go from 0 to 2 pi and it'd be 1 cycle, correct? So your standard graphing for the theta values are going to be from 0 to 2 pi. and in increments that you can choose, but generally we try to stay like pi over 4, pi over 2, 2 pi over 4 pi. And you got 8 coordinates to calculate. Okay. But some of these are circular, they look like rose petals and all sorts of funky stuff, so you kind of have to do all 8 of those if you're going to graph it by hand. Okay. Okay. 0, what is R? 1. Okay, this is a real test of if you get a circle. Okay. If theta is pi over 4, root 2 minus 1. Okay, pi over 2 is 0 minus 1, negative 1, right? And then you go through all the way to 2 pi. No, you don't need to. This is usually about as minimal as you need to get. Okay, what's 3 pi? Negative root 2 over 2, so negative root 2 minus 1, negative 2.414. It's really handy to know the decimal of root 2, 1.414 in this case. Cosine of pi is negative 1, so that's negative 3. 4. Go ahead and calculate the rest of them out. 3 pi over 2, 7 pi over 4, and 2 pi. Should be the same as that. You can see they usually repeat. What'd you get by power 4? Okay. Oh, it's symmetric. How about that? Okay. What does a negative radius mean? Right. I'll show you. Oh crap, I hadn't thought about that one. Since I can't find my grid, we'll just have to agree on this one. Radiuses from 0 to 3. Zero is theta. 1 is the radius. That's 1 for radius, 0 for theta, correct? Okay. Pi over 4 is 0.414. It's somewhere in here. Not exactly perfect, but it'll work. All right, pi over 2, negative 1. Pi over 2, right? What do you think negative 1 means? This would be positive 1. This would be negative 1. So it goes the opposite direction. So pi over 2, 1 would be here, correct? Negative 1 goes opposite. It's the negative radius. 3 pi over 4 is here, but we're at negative 2.414. And then pi is here, but it's negative 3. Now it's symmetric, so you can continue plotting points if you want, but it's gonna do this, this number.
It's kind of like the Hamachi. Oh.
I think this is the cardioid, if I remember right. That's what it's called.
So it goes all the way around.
It kind of looks like a heart, yes. Yeah, so one cycle starts here, goes all the way around, and comes back to the start. And if you did 2 pi to 4 pi, it would just repeat, right? So we're good to go. A lot of times on the AP exam, the area volume problem is, or the area problem is a polar fluidity problem. So we'll go over that tomorrow exclusively. So what would be, or Tuesday, sorry. So tomorrow you get other stuff.
Yeah.
So the question would be, what's the area inside this lobe of the cardioid? So, yeah, and we'll give you some methods to calculate polar area. Okay. Any questions? Are we good? Think you can handle those? If you're practicing graphing polars, is it? You get some pretty neat designs. Oh, you want a calculator example? Yes or no? I'll take that as a yes. Thanks for answering. It's pretty easy. Guess what? Oh, we did a great job. Area for sure.
Wow.
Hi, I'll be done in 3 minutes. What the? No.
No.
Mode? Guess what? Polar.
Whoa.
Okay, that's pretty mind blowing, isn't it? And then you get R, and we just did 2 cosine theta minus 1. And then your window is going to change. So, just grab this. Okay, so my window is only set to see part of it.
You use it.
Let's do negative 2. Yeah, that would probably work too. You'll have to forgive me, I'm a little slow. There you go.
No, that's all. Or do you-
Right. Well, let me give you your assignment so you can get some work done.
More work. Yay! I did last time.
Did you really? When?
I tried to pick
Chapter 11.
shapes that are kind of similar to what you might see on the AP exam. We don't really throw anything much difficult at you, but there are a variety that they do put on there.
What did you ever check? No, the school's freezing.
There you
So
go.
I could go outside if you want.
Draw.